Good day, math enthusiast! Welcome to TLC Math Made Easy. In this video, I will be discussing about the two kinds of variation, which are the joint variation and combined variation. So sit back, relax, and let's learn together. So at the end of the session, you are expected to illustrate situations that involve joint variation and combined variation, and solve problems involving the concept of joint variation and combined variation. Consider the two sets of rectangle ABCD and rectangle EFGH. If the length of rectangle ABCD is 3 units, and its width is 2 units, what is its area? By counting, we get 1, 2, 3, 4, 5, 6. The area is 6 square units. For rectangle EFGH, if its length is 6 units and its width is 2 units, then what is its area? By counting, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the area is 12 square units. We just simply get the area by multiplying the length and the width. So what happens when the length is doubled and the width is unchanged? What happens to the area? That's correct. If the length is doubled, 3 becomes 6, that's doubled, and the width remains unchanged, the area is also doubled. 6 becomes 12, or 6 times 2 is 12. Now let's have another set of rectangles. Rectangle IJKL and rectangle MNOP. If the length of rectangle IJKL is 5 units and its width is 2 units, then what is its area? Okay, that's correct. The answer is 10 square units. For rectangle MNOP, the length is 5 units and its width is 4 units, then what is its area? That's also correct. The answer is 20 square units. As you can see that the length of the rectangle remains unchanged while the width is doubled. So what happens to the area if the width is doubled and the length remains unchanged? So you can see that the area is doubled. As you observe, the area of the rectangle varies directly as the product of its length and width. That is, the length of the rectangle is doubled and its width is unchanged, its area is doubled. Likewise, if the width is doubled and the length is unchanged, its area is also doubled. If this is the case, a joint variation exists. So what is joint variation? Joint variation occurs when one quantity varies directly as the product of two or more other quantities. That is, y varies jointly as x and z if there exists a non-zero constant k such that y equals k x z, where x is not equal to 0 and z is not equal to 0, and the constant k is called the constant of variation. Now let's have some examples. find an equation of variation where m varies jointly as b and c, and m is equal to 24 when b is equal to 3 and c is equal to 4. So m varies jointly as b and c. So we have to translate this statement. M varies jointly is equal to k as b and c, that is b times c. So the equation would be m equals k b c. Next, we have to substitute the values. If m is 24, then we have to substitute 24 to m equals k, b is 3, and c is 4. So 24 equals k times 3 times 4, and 3 times 4 is 12. So we can write that as 12k. So to solve for k, we divide both sides by 12. So therefore, we get k, 24 divided by 12 is 2. So what would be the equation of variation? Again, we have the equation m equals kbc, and we have the derived value of k, which is 2. So we just have to substitute that. M equals 2bc. So this is the equation of variation. The area of a triangle varies jointly as its base and height, and the area equals 21 square units when its base is 6 units and its height is 7 units. Find the area of a triangle when its base is 9 units and its height is 8 units. So we have to translate the given into mathematical statement. The area varies jointly as its base and height. So let's say the area, let A be the area, varies jointly equals k as its base. Let's say this is b, and times, and then height be h. So the equation that we're going to use is A equals k times b times h. Now, if the area is 21 square units, so we substitute 21 to A here, and base is 6, we substitute 6 to B, and height is 7, so we substitute 7 to H. So 21 equals k, 6 times 7 is 42, and k times 42 can be written as 21 equals 42k. To solve for k, we divide each side by 42. So therefore, k is equal to 21 over 42 can be written in simplest form as 1 over 2, since 21 and 42 are both divisible by 21. So 21 divided by 21 is 1, and 42 divided by 21 is 2. So therefore, the constant of variation is 1/2. Now find the area of a triangle when its base is 9 units and its height is 8 units. So we just substitute the values to our equation. A equals k times b times h. So area is equal to k, that is 1/2. Base is 9 units and height is 8 units. So area is equal to 1/2. 9 times 8 is 72. So 1 times 72 is 72 all over 2. So 72 divided by 2 is 36. So the area is 36 square units when the base is 9 and the height is 8. Is this clear? Number 3. If y varies jointly as x and z, and y equals 45 when x is 15 and z is 14, find y when x is 21 and z equals 8. So let's translate first y varies jointly as x and z. That is y equals k x z. Y is 45. So let's substitute 45 to y equals k. X is 15 and z is 14. So k times 14 times 15. We can do cancellation before multiplication. So to solve for k, we divide both sides by 14 times 15. So we can now cancel 14 and 15 here. So we get k equals 45 over 14 times 15. 45 and 15 are both divisible by 5. So when we divide 45 by 5, the answer is 9. And 15 by 5, the answer is 3. But then again, 9 and 3 are both divisible by 3. So if 9 is divided by 3, the answer is 3. And 3 is divided by 3, the answer is 1. So what's left is k equals 3 over 14. Now find y when x equals 21 and z equals 8. So to solve for y, we substitute the values of k, x, and z. So y equals k, x, z. Y equals k is 3 over 14, x is 21, and z is 8. 21 and 14 are divisible by 7. So we can now cancel 21. 21 divided by 7 is 3. 14 divided by 7 is 2. Next, 8 can be divided by 2. So 8 divided by 2 is 4. So what's left is 3 times 3 times 4. So we get 3 times 3 is 9. 9 times 4 is 36. So y is equal to 36 when x is equal to 21 and z is equal to 8. Combined variation. Adi and friends are going on a trip. They agree to share equal with the expense on the amount of gasoline consumed. What can you say about the amount that each one is going to spend in regard to the amount of gasoline consumed and the number of persons whom the gas expense is to be divided? Alright, so we can say that the money they are going to spend on gasoline varies directly to the amount of gasoline consumed, while the share of each one must pay varies inversely to the number of persons whom the gas expense is to be divided. Therefore, the cost C varies directly to the amount of gasoline G, and inversely to the number of persons P whom the gas expense is to be divided. So this kind of variation, which involves both direct variation and inverse variation is called the combined variation. And it can be presented as y equals kx over z, that is y varies directly as x and inversely as z if there exists a non-zero constant k, where z is not equal to 0. The constant k is called the constant of variation. Y varies directly as x and inversely as z. If y equals 10 when x equals 4 and z equals 2, find the constant of variation. So let's translate first y varies directly as x and inversely as z. So y varies directly as x. So we can write that as y equals kx, and varies inversely as z, that is over z. So therefore, the equation of variation is y equals kx over z. Next, what is the equation of variation? Since y equals 10 when x equals 4 and z equals 2, so let's substitute the given values to the equation. Y equals 10, x equals 4, and z equals 2. Or this is the same as 10 equals k times 4 is 4k over 2. So we can divide 4 and 2. So 4 divided by 2 is 2. So we have 10 equals 2k. And to solve for k, we divide both sides by 2. So therefore, k is equal to 10 divided by 2 is 5. So the equation of variation would be y equals kx over z. Since the value of k is 5, then we have y equals 5x over z. So this is the equation of variation. Next, find y when x equals 9 and z equals 15. Since we have the equation y equals 5x over z, then to solve for y, we have 5, x is 9, and z is 15. So 5 times 9 is 45 over 15, and 45 divided by 15 is 3. So therefore, y is equal to 3 when x is equal to 9 and z is equal to 15. Is this clear? Number 2. If a varies directly with the square of b and inversely as c, and a equals 1 when b equals 2 and c equals 10, find a when b equals 4 and c equals 5. So we have to translate a varies directly with the square of b and inversely as c. So we write that as a equals varies directly as the square of b and inversely as c. If a equals 1, so we substitute 1 to a equals k. B is 2, so we have 2 squared, and c is 10. So 1 equals 2 squared is 4. 4 times k is 4k equals over 10. So we transpose 10 here, or we multiply the whole equation by 10. So 10 times 1 is 10 equals 10 times 4k divided by 10 is 4k. So this is the same as 4k equals 10. So to solve for k, we divide both sides by 4. So k equals 10 over 4. And 10 over 4 in simplest form is 5 over 2. That is 10 and 4 are divisible by 2. So 10 divided by 2 is 5 and 4 divided by 2 is 2. So the value of k is 5 over 2. Now find a when b equals 4 and c equals 5. Again, we have the equation a equals k b squared over c. So we have a, the value of k is 5 over 2. The given value of b is 4. So 4 squared. And the value of c is 5. So a equals 5 over 2. 4 squared is 4 times 4. That is 16 over 5. 16 can be divided by 2. That is 8. So we have 5 times 8 is, let's have here, 5 times 8 is 40 divided by 5. And 40 divided by 5 is 8. So therefore, the value of A is 8 when B is 4 and C is 5. Number 3. M varies jointly as N and P and inversely as Q. If M is equal to 4 when N is equal to 5, P is equal to 8, and Q is equal to 20, find M when N is equal to 3, P is equal to 10, and Q is equal to 12. So let's translate M varies jointly as N. So we have M equals K, N, P, and inversely as Q. Now let's substitute all the values here. M is 4, N is 5, P is 8, and Q is 20. 5 times 8 is 40. So 4 equals 40 times K is 40K over 20. Since 40 can be divided by 20, so let's divide this. 40 divided by 20 is 2. So 4 equals 2K, or this is the same as 2K equals 4. So to solve for K, divide both sides by 2. So K is equal to 4 divided by 2 is 2. Now find M when N equals 3, P equals 10, and Q equals 12. So to solve for M, we substitute all the values. M equals K and P over Q. M equals value of K is 2, value of N is 3, value of P is 10, and value of Q is 12. M equals 2 times 3 times 10. 2 times 3 is 6. 6 times 10 is 60 divided by 12. So 60 divided by 12, that is 5. So M equals 5 when N equals 3, P equals 10, and Q equals 12. Is this now clear? I hope that everything is clear. Now let's have some practice exercises to see whether you understand the concept of joint variation and combined variation. Translate each into a mathematical statement. Use K as the constant of variation. So you have 5 seconds to answer. Number 1. Q varies jointly as S and R. Alright, the answer is Q equals K S R. Next, R varies directly as M and inversely as N. Alright, R equals Km over N. How about number 3? X varies directly as Y and inversely as the cube of Z. Alright, X equals Ky over Z raised to 3. Number 4. A varies jointly as B and the square of C and inversely as D. Okay, A equals K B C squared all over D. Did you get all those correct? Next, determine whether its equation represents direct, inverse, joint, or combined variation. Number 1, M equals 3 over N. If your answer is inverse variation, then you are correct. Number 2, M equals N over 4. You have 5 seconds to figure it out. Alright, the answer is direct variation. Next, number 3. A equals to 3B over C. What kind of variation is this? Alright, it's a combined variation. Number 4. X equals 1/2 YZ. Okay, the answer is joint variation. And last one, C equals AB over 2. Alright, the answer is joint variation. I hope that you learned from this video. Thank you for watching, everyone.